Okay, question 6 says, sketch the polar curve r equals 2 minus 2 cosine theta by plotting points. All right, so let's start out. Let's go ahead and build a table of values, where in the first column I have values for theta, and here I'm just taking steps of pi over 4. So 0, pi over 4, pi over 2, 3 pi over 4, pi, and so on up until we get to 2 pi. And then in the second column, I have the corresponding values for r, where I find those by just plugging in these values for theta into this equation. Okay, so when theta is 0, r is 0, because the cosine of 0 is 1. When theta is pi over 4, I'm going to get 2 minus the square root of 2, and that's because cosine of pi over 4 is root 2 over 2, and so when you double here, you get the square root of 2, and this quantity is about 0.59. All right, and then 2 for r when theta is pi over 2, and then 2 plus the square root of 2 for r, which is about 3.41 when theta is 3 pi over 4, and then r reaches its maximum value of 4 when theta is pi. And then notice for the remaining values, we're just mirroring what we're getting on the interval from 0 to pi. All right, so now to plot the corresponding points in the xy plane, I'm going to go ahead and include these dashed lines for the rotation angle theta just to serve as guides. And so when theta is 0, r is 0, telling us that we're just at the origin when theta is 0. And now if I rotate from 0 up to pi over 4, my radial distance r will increase from 0 up to about 0.59. Okay, so I'm going to go ahead and put these dots in the picture. So we're rotating from 0 up to pi over 4, and my radial distance r will increase from 0 up to about 0.59. Then if I rotate from pi over 4 to pi over 2, my radial distance increases from 0.59 to 2. And then rotate to 3 pi over 4, your r value will increase from 2 to about 3.41. That's right here. And then if you rotate to pi, r will increase from about 3.41 to its maximum value of 4. Okay, so at this point right here, on the negative x-axis, we are 4 units away from the origin. All right, and then as we noted in the table, we're just going to mirror what we did on the interval from 0 to pi. So you can see we then decrease r down to about 3.41, then down to 2, then to about 0.59, and then back to 0. Okay, so if I draw a nice continuous curve through these points, I get this yellow curve, which looks like a heart on its side, and for that reason this is known as a cardioid curve after the Greek word cardia, which means heart. Okay, so that does it for this question, but I do want to add a couple more things here before we finish. And the first is that if I look at this polar equation, r equals 2 minus 2 cosine theta, and I think about its graph in the r theta plane, well, when theta is 0, r is 0, and then as I increase theta, r increases and reaches a maximum of 4 when theta is pi, and then we decrease back to 0 when theta is 2 pi. Okay, so looking at this graph in the r theta plane, okay, note that as I move from left to right, I'm increasing theta, so up in the xy plane, that corresponds to a counterclockwise rotation. Okay, and the points on this green curve are telling me my radial distance from the origin as I rotate counterclockwise. Okay, so you want to have in your head that when theta is 0, r is 0, so we're starting here at the origin. And now as we start to rotate counterclockwise, okay, our radial value is going to increase and reach a maximum of 4 when theta is pi. Okay, so you want to think about rotating and increasing your radial distance as described by this green curve down here, and we're going to hit a maximum radial distance of 4 when theta is pi. And then we're going to decrease that radial distance back to 0 as we rotate through this angle from pi to the angle 2 pi. Okay, so that's what you want to have in your head there, thinking about how this curve in the r theta plane relates to our curve in the xy plane. Okay, now let's look at that very same thing in Desmos, a little more dynamic. So here is our cardioid in blue, r equals 2 minus 2 cosine theta. So if I go ahead and plot r equals 2 minus 2 cosine theta, where here I'm thinking about the horizontal axis as theta and the vertical axis as the radial distance r. Okay, as I move from left to right here, okay, the points on the green curve are going to describe the radial distance from the origin on the blue curve. Okay, so here a, this parameter, is describing my rotation angle. So as I increase from 0, I can see that, okay, my radial distance on the green curve is increasing, and I can see that that's the case on the blue curve. And then I reach this maximum radial distance at pi, where r is 4, and then I'm going to decrease back to 0. Okay, very nice. Last thing I want to note here, this is something that we saw in the last video. If I replace cosine of theta with sine of theta, well, that's equivalent to replacing theta with pi over 2 minus theta from the complementary angle identity. Okay, and so that gives rise to a rotation counterclockwise by 90 degrees. So if I replace cosine theta with sine theta, I get this curve in green, which is just obtained by taking this blue cardioid and rotating it counterclockwise 90 degrees to get this green cardioid. All right, very nice. Well, that's a good place to stop. I'll see you in the next video. Thanks.